solve 2 sine x minus 1 equals 0. Okay, to do this, we need to solve for the sine of x. We need to isolate it, so we need to get everything on the other side. So first thing, we want to add 1 to both sides, so get 2 sine of x equals 1, and then divide both sides by 2. Okay, so basically what we're looking for is the angle, so x represents the angle for which the terminal point, the y-coordinate, because we're talking sine, and remember sine is the y-coordinate of the terminal point, is 1/2. So now you're going to have to do this by memory on the test, but just for this exercise, let's look at the unit circle, just to remind ourselves where this is. So as we look at the unit circle, notice that there are 2 places where the sine of x is positive, and where it's 1/2, a positive 1/2, and that's right here and right here on the unit circle. It's in the first and second quadrant because that's where sine is positive. So we look at those angles. So the first angle is x equals pi over 6. So right there. Now remember that this is not the only angle though in this position. So if we have this ray that represents the angle, if we go around the circle 360 degrees or 2 pi, then we end up in the same place. So any angle that ends up in the same place has that same sine of x. So to signify all the possible solutions for this, we put plus 2 pi n, where n represents the number of times we go around the circle. Now the second solution here, it happens at 5 pi over 6. It's on the other side, it's in the second quadrant. So x equals 5 pi over 6. And again, if you notice, we have this ray right here, but again, as we go around the unit circle 360 degrees and end up in the same place, it's a new angle, same solution. So we need to, again, make certain that we include that in our solution. So we add 2 pi and in this case 2. So those are our 2 answers for this problem. Now the second problem is slightly harder, just in the sense that now you have to factor. It's a quadratic type of equation. If it helps to substitute just x instead of cosine x for the factoring purposes, go ahead. But we're going to do it in terms of cosines. So remember, we're factoring a quadratic. So in this case, we're going to get cosine of x plus 1, and then cosine of x minus 3. And it's equal to 0. So now we can use the zero product property, and we split it up into 2 pieces. So cosine of x plus 1 equals 0, and cosine of x minus 3 equals 0. So we solve it. Cosine of x equals -1, and cosine of x equals 3. So right off the bat, we notice a little problem, which is with the second one, cosine of x equals 3. That cannot happen. This is not a number you will find on the unit circle. And remember, as you have your sine wave, the highest point is 1 and the lowest point is -1. So you cannot get 3 as an answer. So we have no solution for this part. But we do get a solution for the first one. So again, let's take a look at the unit circle. And remember, on the test, you will have to do it without. You'll have to draw your own unit circle. But we want to look at where is cosine of x equal to -1. Now remember, cosine is the x-coordinate. And actually, there's only one place where the x-coordinate is equal to -1, which is down here at pi radians. So that's actually our solution, x equals pi. But just as we talked before, this is technically not the only solution, but in that position, that's the only position that we can find this in. But there are multiple solutions as we go around the circle. So to signify this, we put plus 2 pi n. And that will give us all possible solutions for that particular angle.